Alright guys, so here we go. We're starting lesson 4. We're going to work on ratio tables, which is on page 39 to 45. The essential question again is, how do you use equivalent rates in the real world? That's for the whole chapter. This lesson has actually 2 goals. 1, you're going to use ratio tables to find equivalent ratios. And goal number 2, you're going to use scaling to make equivalent ratios. So it's all about equivalent ratios and how to find them and how to make them and how to determine if they are equivalent. Okay. Now, the vocabulary for this lesson, there are 3 words: ratio table, scaling, equivalent ratio. Again, for the moment, please use book definitions. Okay? Or whatever definitions I give you here in the notes. Okay? Alright, so here we go. Goal number 1. It's all about equivalent ratios. All right. So, what is it? I might as well tell you what it is first, right? Before we even talk about ratio tables. All right. Equivalent ratios express or show the same relationship between quantities. Okay? And I want you to focus on this word, relationships. Okay? So, I'm going to make this very, I don't want to say simple, but I want you to understand the idea. If I say there are 2 circles for every 1 square, again, circle to square, the relationship is 2 to 1. Okay? 2 to 1. That's the relationship. So now if I tell you I have 4 circles and 2 squares, it's still a relationship. What happened? I multiplied 2 to 1, and I have 4 to 2. Oh, this is why you use pencil, folks. Got a little too confident there. That's okay. I'm going to fix this. I could edit it out, but you know what? No. 4 to 2. So while that dries, I'll fill it in later, but I want you to understand one thing. To go from here to here, I multiplied by 2. And just so you can see it, I hope this works. There you go. There's a relationship. Look. 2 to 1 is the same as 4 to 2. Why is that? I have 2 of these. I know it looks like a little face. If you want to see it like a face, that's fine. But this is the same as this because they express the same relationship. Alright? It's 2 to 1. 2 to 1 twice. Okay? So those are equivalent ratios. These 2 are equivalent. Not equal. Equivalent. They express the same quantity, the same relationship, but not the same numbers. Okay? So that is an equivalent ratio. Okay? Again, use pencil. That's my goal. But a way we can find equivalent ratios, besides doing like this, and if you notice, it's really times tables here, you know? Now, I don't know if you remember your times tables or not, but let me express something to you. You might have seen your times table before where you have numbers like this, and then times 1, times 2, times 3, times 4, right? 2, 4, 6, 8. So you know what a times table looks like, right? This is a times table. Times table looking thing. Right? And if I give you another number, again, here's the 1. 1 times 1, 1 times 2, 1 times 3, 1 times 4. And you know what? I'm going to highlight this with or darken it so you can see the difference. It's like a times table. So ratio table, let me give you a definition for this real fast. A ratio table helps you find equivalent ratios. Okay? It's a way to organize them, all right? It helps organize ratios too. All right. So we have our definitions now. Okay? We have our definitions. Equivalent ratios, ratio tables, and again, I want you to focus on this word relationship. All of math is sooner or later comes down to relationships. How is one thing connected to another? All right? Now, I'm going to go ahead and do example 1 on page... What page is this? I should know. I have the book in front of me too. Page 40. I think we have space here. Let me just be... see if I can be efficient here. Example 1, page 40. To make yellow icing, you mix 6 drops of yellow food coloring and with 1 cup of white icing. How much yellow food coloring should you mix with 5 cups of white icing to get the same shade? Okay. All right. As I said before, the first thing you should do is write down the words. What is it we're comparing? What are the nouns? Don't give me the numbers. Give me the words. What are we comparing? Always write down the words. Now, if I read this correctly, we're comparing drops of yellow with cups of icing. Now, I'm not a baker. I'm not going to pretend to be, but I do understand if you've bought cakes before, you have the little canisters of frosting. In my head, I'm imagining frosting. Even though it says icing, I'm imagining frosting. All right, so we have our words, right? Now, it says here, for our basic recipe, we need 6 drops of yellow to 1 cup of white icing, okay, to get a shade of yellow. Not too dark, I'm assuming, right? But this would be enough for a small batch, right? So what if you're making a bigger cake and you need more icing, more frosting, right? We're going, okay, we're going to use 5 cups of icing because that's how much cake we have to cover, whatever, right? And I want you to notice, it's just times tables all over again. To go from 1 to 5, multiply by 5. And since this is acting like a fraction, whatever you do to the denominator, you do to the numerator. Okay, so the answer is you add 30 drops of yellow. Okay. By the way, when you're getting more, I'm phrasing it like a question, getting more, okay, you are scaling up. Okay. So far, so good. It's like you're literally scaling up. All right. So that was example 1. We're going to work on the got it's. We're still working on equivalent ratios. All right. All right. We're going to look at got it. The got it. Page 40 still. And this is letter A. A patient receives 1 liter of IV fluids every 8 hours. At that rate, how many hours will it take to receive 4 liters of IV fluids? Okay. You may not know the language, but that's okay. IV fluids. If you've ever watched hospital dramas or hospital shows or any place, any TV drama or anything where there's a hospital scene, these patients, you see them, they're hooked up to little bags of, looks like water, but it's supposed to be intravenous fluids like sugars and whatever else they need. The point is, it's bags. You've seen them, bags of fluid. So IV fluids, and we're measuring it by time in hours. And actually, I should put down here, we're measuring in liters. right? So let me say it again. A patient receives 1 liter of IV fluids every 8 hours. At that rate, how many hours will it take to receive 4 liters of IV fluid? So again, you know, it's one of those things where you've been doing this all along. It's just this time they put it in little boxes, right? You have the ratio of 1 to 8. You've done this before, right? And so the question is, if we want 4 of these, how long do we have to wait? So again, the relationship. We're scaling up. We're going up. We're getting more. How many groups of 1 do we need to get to 4? Times 4. Now, like I said, whatever you do to the numerator, you do to the denominator, right? Whatever you do to the top, you do to the bottom. Whatever you do to the bottom, you do to the top. So again, if the relationship is times 4, it's 32 hours. Okay, I realize it's a lot of words. You're like, I don't get it. I mean, you might understand the math, but you don't understand necessarily what's going on. So let me see if I can make the next one easier, all right? It's going to take a little while, but I'm going to make it very visual if possible. All right, to make cranberry jam, you need 12 cups of sugar for every 16 cups of cranberries. Find the amount of sugar needed for 4 cups of cranberries. Okay. Oof. I picked the wrong one. That's all right. So sugar and cranberries. Okay. Cranberries are going to be harder to explain. They're berries. But if you really want to know what they look like, please look online. Again, anytime you see a word that you don't understand, please look it up online. There's no shame in doing that. Okay? So, 12 to 16. That's our ratio. All right, let's see if I can do this correctly. Let's make this pink. And let's make this one yellow. So the relationship so far, we have 12 to 16. 12 to 16. That's our ratio, 12 to 16. All right, 12 cups of sugar to 16 cups of cranberries. All right. Now, in this, we have another ratio. We need to find another ratio. And then we have a third ratio over here where it asks, okay, all right. We want to end up with 4 cups of cranberries only. So guess what it's asking is, we have all these cups of sugar, all these cups of cranberries, but it looks like you started out with the simplest form and you made more, right? Maybe this batch was good for like 4 people or something, but maybe your family came over, now you have to make more for whatever reason. But maybe your sister, again, I'm making a story out of this because it'll help me remember, but maybe your father asked, hey, I like what you did there, I want the recipe, but I don't want to make this much. What if I just want for 4 people? What was the original recipe, right? Okay, we're looking at relationships. Again, relationships. Always about relationships. All right, 12 and 16. What's going on? It looks like they're both even numbers, so I can divide by 2. Right? And if I do that, 12 divided by 2 is 6. 16 divided by 2 is 8. Right? Does that make sense? All right. So let me show you what happened. That was a little sloppy there, but it's okay. So what just happened? I made 2 groups. 2 groups, group 1, group 2 of 6 to 8. 6 to 8, you can see it. I took this and split it right down the middle. 6 to 8, 6 to 8. But now I just want 4 groups. I'm going to take the 6 to 8 here. going to take this one group and make it so that I only have 4 cups of cranberry. Alright? So how's that going to happen? Basically, if I do this, if I draw right down the line, I can see that I'm going to have 2 groups of 4, right? Here, let me see what's going on. Again, 6/8. We have one big group of 6, one big group of 8. We have it twice, but don't worry about that. We're making it smaller and smaller. We're going from a big group to a smaller group, and we're going to make this even smaller. We're going to divide this by 2. I should be using pencil. Alright. 8 divided by 2 is 4. 6 divided by 2 is 3. So what's going on? Look, I'm going to continue this over here. This is still 6 to 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. What this just said, divided by 2, it means, oh, guess what? I'm going to break this up into 2 groups. And it looks like if I can imagine in my head, I put a line right down the middle, I'm going to have 2 groups of 3. Right? So this breaks up into, and just for the sake of, I'm going to draw the arrow there. This breaks up into 2 groups of 3. 1, 2, 3. 1, 2, 3. This breaks up into 2 groups of 4. 1, 2, 3, 4. 1, 2, 3, 4. And it makes sense. The 2 means I have 2 groups now. 2 groups of 3 to 4. Right? So let me show you the math, what just happened. We went from 12 to 16 to 6 to 8 to 3 to 4. These 3 ratios are equivalent. I know, you're probably saying, why aren't you using pencil? I'm hoping I don't make a mistake here. These 3 ratios are equivalent. It all starts with 3 to 4. 3 to 4. Right? 6 to 8 is 2 of these. It's the same relationship of 3 to 4. Just twice. 3 to 4, 3 to 4, just twice. Which leads us to 6 to 8. And then if you go to the bigger number, 6 to 8. There it is. If I multiply by 2, 12/16 is just 2 of these. 12/16 is just 2 of these. That's relationship. They're equivalent. They express the same idea of 3 to 4. You don't believe me? Look. Look. I'm kind of tempted to not write on this because it looks so clean. You know what? I won't. I'm going to save that. I'm going to show you on the next page what's going on. Three to 4 is equivalent to 12/16. In this case, I'm scaling up. So let me show you what's going on. The times 4 tells you you're going to make 4 groups of these. 4 groups of the 3s. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And the bottom number, I'm going to have 4 of these. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 4. These are equivalent. Again, the idea is 12/16 is just this 4 times. They have the same relationship of, for every 3 cups of sugar, you have 4 cups of cranberries. 3 cups of sugar, 4 cups of cranberries. 3 cups of sugar, and so forth and so on. Alright? By the way, I forgot to mention in the other example that I just showed you, when you're going when you're getting smaller, you're, guess what, scaling down. Okay? You're like, may seem obvious now. Getting smaller is scaling down. Okay? We'll give more detail on that later. Okay, this leads us to, guess what? Goal number 2. We're almost done here, guys. I know it's already been 20 minutes. We're almost here. We're going to use scaling. Okay? And actually, we've been doing that all along. So here we go. Use pencil. Whoops. All right. I'm going to give you the definition the book tells you because it's pretty good, actually. Scaling. It says multiplying or dividing two related quantities. Oh, I love the technical definition. By the same number. Kind of gave you a preview already. It's called that was a weird eye, wasn't it? That's really an eye. It looks like an L with a dot at the top. Apologize for that. There you go. Okay. Again, real quick example. 1/2 to 2/4. Two quantities, maybe sugar to cranberries, right? Times 2, times 2, this is scaling up. Eight sixteenths. Again, you're dividing by 8, you're scaling down. Again, the numbers can represent anything. Again, it could be cups of sugar, cups of cranberries, just like in the previous example. If you're going down, you're scaling down. If you're going up, you're scaling up. Okay? So be aware, I'm going to be using this this word a lot. Okay? Don't worry, we're almost done here. We're almost done. All right. Let's do example number 4. I think we have enough space. Let's give it a shot. And this is page 41. All right, I will read the problem to you as best I can. Joe mows lawns during the summer vacation to earn money. He took 14 hours last week to mow 8 lawns. At this rate, how many lawns could he mow in 49 hours? All right. All right. We're comparing two things. Right? We're comparing two things. What is it we're comparing? We're definitely comparing hours to lawns. Right? So it tells us he took 14 hours last week to mow 8 lawns. Again, always take care of the English first. Hours, what are the nouns? Always get the nouns down first. Hours to lawns. Okay? It says he can do 14 hours. And in those 14 hours, he can do 8 lawns. So he's cutting the grass, mowing the grass, whatever you want to call it. All right. Then the question is, well, hey, at this rate, how long will it go? How long will it take to get to 49 hours? Does that make sense? No, that didn't make sense. Let me restate it again if I can erase this. And my eraser just disappeared. It left me. It went bye-bye. Oh, should I cry? Now there it is. Found it. Ta-da. Okay. So let me see if I can make more sense of it, because that did not make sense what I just said. If in 14 hours you can do 8 lawns, and you know what, if you want to make drawings, that's fine, but I think you guys get it. How many lawns can he do in 49 hours, right? That's what we don't know. Okay, here's the situation. It looks like we're scaling up, right? Now, is there any whole number I can multiply by 14 to get 49? In other words, if I'm making groups of 14, is it possible to make 49? No. No. So if that happens, if you can't scale up, then consider scaling down. Okay? If I can't multiply to get to the answer, maybe you need to multiply to something smaller in the middle, right? Don't worry, I'm just drawing boxes. It should be pretty safe for me to draw boxes. All right. They're both even numbers. If I scale down by 2, this gives me 7, this gives me 4. Okay, now we're getting somewhere. Can I scale up now to go from 7 to 49? Yes. Now guys, at this point, realize it's just a game. Play with it. If you make mistakes, so what? Right? So of course now you got to write a sentence. He can, look at that. Who knew, right? He can mow 28 lawns in 49 hours. And by the way, you don't have to say it like that. You can say in 49 hours he can mow 28 lawns. But the idea is the same. It gives you the information you need. All right, so let's do the got it, letter C. Letter C, again, page 41. A child's height measures 105 centimeters. Estimate her height in inches. All right. Height in centimeters. And we're comparing height in inches. Okay. Well, you can't see what I just did. There it is. Height in centimeters, height in inches. All right. It tells us 25 centimeters goes with 10 inches. So I guess the ratio is for every 25 centimeters, it's the same as 10 inches. All right. Now here's the problem. And it'll look very similar to what we just did. Our question is, all right, if we know the height is 105 centimeters, and it's the same kind of ratio, the same relationship, what would the height be in inches? This is what we don't know. Okay, same thing. Now, if you notice, I keep leaving space in the middle because I might have to scale down. So if I have to do that, if I have to simplify, I'm giving myself space to do it. Okay, I can't think of any whole number that can multiply by 25 or multiply 25 by to get 105. So if I'm making groups of 25, like let's say 25 cents, if I multiply by 4, that gives me $1, right? There's no way I can get 105, right? Or let me put it this way. 25 times 4 gives me 100. There's no way I can get to 105, not with a whole number. Okay? So if scaling up isn't going to work, then scale down perhaps. And again, I'm going to draw the two boxes with the pen. All right. Let's scale down. Is there a common factor? Now, it ends in a 5 and a 0. That means I can use a 5. Right? If I have 25 and I'm breaking it up into 5 groups, that means each group's going to have 5. If I have 10 and I'm breaking it up into 5 groups, that means each group's going to be 2. Okay. So for every 5 centimeters, it's really 2 inches. So 5 centimeters is the same as 2 inches. All right. Now, I'm pretty sure I can scale up to that. 5 times some number will give me 105. Now, if you can't figure out the multiplication this way, you can keep adding 5. 5 plus 5 plus 5 plus 5 till you get to 105. And then just count how many 5s you added. Or you can divide. 105 divided by groups of 5 is how many groups are you going to get. All right, so let me write it just a little differently, because I know in my head what it looks like, but obviously you can't see what I'm thinking, and I want to make sure you understand what's going on. 5 times something equals 105. Going this way, right? If I go backwards, it becomes 105 divided by 5 equals that, right? Now some of you may know, I'm just going to tell you why that worked. When you multiply, you can change the order. So in my head, I kind of did this. Now it makes more sense when I go backwards. It'll look like this. Okay. But anyways, let me do the division. 5 is the dividend. Sorry, 5 is the divisor. Apologize. 105 is the dividend. All right. I know, some of you are like, I don't like long division. It's not. Let's make it simple. You're making groups of 5. 5, 10, 15, 20, that kind of deal. Can I make groups of 5 out of 1? No. Can I make groups of 5 out of 10? Yes. How many? 2. It's just times tables. 5 times 2 is 10. Bring down the 5. How many groups of 5 can I make from 5? 1. And you have nothing left. Okay. So the answer is 21. So you can already see what's going to happen. I'm going to multiply 5 times 21. That's great. I get this. Do the same thing here. What's 2 times 21? 42. Now, just for the sake of argument, I'm going to do the work here. All right? But you need to write a sentence. You know that. Her height. Is it her? That's the child. Oh, could be a girl, could be a boy. I'm going to say her. Her height is about 42 inches. I'm debating whether I should do another example. You know what? Why not? One more example, one for the road. All right, we have example 5 on page 42. I know I shouldn't be using pen, but it's force of habit. All right, what are we comparing? On her vacation, Leia exchanged $50 American and received $60 Canadian. Use the ratio table to find how many Canadian dollars she will receive for $20 American. So, all right, we're comparing Canadian dollars. I didn't know that. I didn't know Canada used dollars just like we do. All right, and then American. Now, if you don't mind, I'm just going to use the symbol. Canadian dollars, American dollars. Okay, so the ratio according to this is 60 to 50. Oh, man. All right. All right. Not a problem. And then it says, okay, this is the relationship. For every 60 Canadian dollars, you get 50. All right. And then it asks, well, hold on. What if I only have $20? How much Canadian money will I get? Now, I left this space here because maybe I can go directly from here to here, right? You can scale down because it looks like I'm getting a number that's smaller. I want something that's smaller. But from what I'm seeing, I can't scale down from 50 to 20 using a whole number anyways, right? I can't see myself breaking this up to get 20, groups of 20. It's just not going to work, right? But if that's not going to work, then you know what? As I said before, can I scale down to something smaller maybe? Okay, now here's the deal. They end in 0. That means I can divide by 10. All right. If I have 60 and I break it up into 10 groups, I have 6 per group. If I have 50 and I break it up into 10 groups, I have 5 per group. All right. So the simplest ratio is 6 to 5. So for this, I'm going to draw a little picture because I think you guys can see it. So 6 C's is the same as 5 A's. And again, you don't have to do this. I just want you to see what's going on. All right. So 6 to 5. Now, I want to go from, looks like I'm scaling up, right? I'm getting something bigger. I want $20. All right. That means I need 4 of these, 4 groups of 5, right? I'm going to do the same thing there. Okay. The answer is 24. like, you can't see what I just wrote. That's okay, because I will make it come to you. Leia gets $24 Canadian. $24 Canadian. But wait, I said I was going to show you the picture, didn't I? Okay. Here we go with the coloring, right? So 1, 2, 3, 4, 5. And I multiply by 4. Well, you can't see what I just did, can you? All right. 1, 2, 3, 4, 5. And I said I need 4 of these to get to 20. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'm going to circle them so you can see that it's actually 4 groups of 5. There's my 1 group of 5, 2 groups of 5, 3 groups of 5, 4 groups of 5. All right. Now the C's. I'm making groups of 6. 1, 2, 3, 4, 5, 6. But I'm doing this 4 times. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6. Woof. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now see, I love drawing, but sometimes it gets a little tedious. So when you know the math, you know your times tables, you don't have to keep drawing everything. Although again, there's no shame. There really isn't. Whatever gets the job done, short of cheating, and you're fine. All right? Oh, I think I drew too much. I went too far. 1, 2, 3, 4. Forget this part. Ooh, I went too far. See, that's the other problem with drawing. You can get too excited and you overdo it. But there are my 4 groups. Again, 6, 12, 18, 24, 5, 10, 15, 20. 24 to 20. All right? Sorry for the sloppiness. It's late. All right, and that's it for the notes. Hope this helped.